Okay, we got three numbers here. We have one that's in binary, that's base 2. We have one that's in octal, base 8. And then one that's in hexadecimal, that's in base 16. And we want to convert each of these into regular decimal form that we're used to. Okay, the first one, the binary number. Binary means we only use ones and zeros, and that each space is a power of 2. So let's see, we've got 6 digits here, so let's write it out like this. We'll write out 6 spaces. Okay, and then in the beginning of each space, we're going to write these 6 digits. So we have 1, 1, 0, 1, 0, 1. Now the place values for each of these are going to be powers of 2. And we're going to multiply those. So the first one is 2 to the power 0, which is really just a 1. Then we have 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, and 2 to the fifth power. So we simplify these down. 2 to the fifth power is 32 times 1, so that's 32, plus 2 to the fourth power is 16 times 1 is 16, plus, well, 2 to the third power is 8, but that's not really important because we're going to multiply it by 0 anyway, and so that term goes away. 2 squared is 4. 4 times 1 is 4. We have another 0 term, so that goes away, and 1 times 1 is 1. So we're left with 32 plus 16 plus 4 plus 1. So this is the way to write the regular number 53 using binary. Okay, our next one is the octal number, 462 in the base 8 system. Now what this means is all the digits will be 0 through 7, and we use powers of 8. So when we go to write this one down, we're only going to have 3 spaces, because we only have 3 digits. We're going to put the 3 numbers, 4, 6, and 2, at the front of each space. And then this time the place value are going to be powers of 8. So the first one is going to be 8 to the 0, which is, again, 1. Then we have 8 to the first power, and 8 squared. So 8 squared is 64. 64 times 4 is 256. Plus 8 to the first power is just 8. 8 times 6 is 48. And then 2 times 1 is 2. So if we add these together, 256, 48, and 2, we get that the octal number 462 is the decimal number 306. All right. And finally we have the hexadecimal number. It was A42B base 16. Now base 16 means we're using the digits from 0 to 16. However, after 9, the digits aren't single digits, they're double digits. Well, since we got to go 10, 11, 12, up to 15, we use the first 6 letters in the alphabet. A would be 10, B would be 11, C would be 12, D would be 13, E would be 14, F would be 15. So, we've got 4 digits here. So, our conversion is going to have 4 spaces. We're going to put these values at the beginning of each. A, which we said a minute ago, A converts to 10. 4, 2, and B converts to 11. So then we just use powers of 16. 16 to the 0 power, it's still 1. You notice this first one's always going to be a 1. Then we have 16 to the first power, 16 squared, 16 to the third power. And this is going to take a little more calculating. 16 to the third power is 4,096 times 10. So this would be 40,960 plus 16 squared is 256 times 4. That's 1,024. 16 to the first is 16 times 2 is 32. And then 11 times 1 is 11. And then finally we add those together. And so the hexadecimal number A42B is our decimal number 42,027.